Hi everyone, I'm doing this video upon request to be similar to number 11 on homework 4, the paper homework in the second portion, second part of 2.6. So this is a radical equation where we have two radicals. So when we have this situation, we need to first get the radicals on either side. So I'm going to subtract the x plus 2 from both sides, or square root of x plus 2. That's the first step. So we now would have square root of 3x plus 7 equal to 1 minus square root of x plus 2. Now it looks very similar to that homework problem. So no matter which way you start, the problem presents itself to begin with. You want to have it looking as such now. So the next thing I will do is square both sides. That's our typical process. And then you can use your pattern of a perfect square trinomial. When you're just squaring a binomial, you'll get a perfect square binomial. So I'll go through that with you. This left-hand side, though, is pretty simple. You're just going to take the square root. That leaves you with 3x plus 7, so just let that sit there. And then we have equals to all the other stuff. So now I have to square this 1 minus square root of x plus 2. So I am going to take the square of the first term, which would be 1 squared. And then I multiply the two terms together. So I would get minus square root of x plus 2 times 1, and then I double it. So I'm going to put minus, and then that ends up being 2 times square root of x plus 2. If I had a coefficient on there too, I would just include that in there. And then now it's always positive here at the last term. So I'm going to square the x plus 2, or square root of x plus 2. So I get x plus 2. I don't have a coefficient on there, so I don't need to worry. But if I did, I would add that with some, I would square that also and add parentheses around. So maybe I can find another one, or I'll just do out that specific homework problem as well after I do this one. So now we just need to get everything organized, combine like terms, and then we're going to have our expression with the radical. I'm going to leave that on the right hand side. So go ahead and combine your like terms and get everything except this here on the left. Okay, so now what I've done is just I added the 1 and the 2 here to get the 3, and then I subtracted 3 from both sides and an x from both sides. So now I end up with 2x plus 4 equals negative 2 square root of x plus 2. From there, I want to follow my process that you may be more familiar with, is when I just have a coefficient next to, or a multiplier next to the radical. So I'm going to take the square of both, or square both sides, and what I'll get is 2x squared, I should just write that as 4x squared, plus twice the product of the two terms. So if it's 2x times 4, that'd be 8x, and then I double it to get 16x. And then the last term, I just add the square, plus 16. Over here, I'm just going to square the negative 2, give me 4, and then square the radical square root of x plus 2. So do make sure you put that in parentheses there. And then I would distribute. So you can kind of do that in one step if you can track it really well. So then I have 4x squared plus 16x plus 16 equals 4x plus 8. Now what you're going to do is subtract the 4x and the 8 from both sides and set that equation equal to 0, and then you'll have a quadratic and it is factorable. So go ahead and try that and see how you do with that. I'll start writing it out. So before we actually go through with factoring it, we are going to want to factor out a greatest common factor. So we can factor out a 4, leaves us with x squared plus 3x plus 2 equals 0. Then the 4 will just divide out. So divide both sides by 4. I am just left with the x squared plus 3x plus 2 set equal to 0, because anything 0 divided by anything is just 0. So I'm not going to rewrite that, but I just want you to know where that 4 will end up. We don't need it. It's not a 4x or anything like that. So if it were, we would set that equal to 0 too, but we wouldn't ever set a just a constant equal. So we now can factor this x plus 2, x plus 1 should work. Just double check. 2x in the middle plus a 1x gives me my 3x, so I'm good there. Set each factor equal to 0, and I get x equals negative 2 or x equals negative 1. Now be careful because you do have to verify, so I'm going to do that off to the right hand side there, and then you do it as well and check on how you do. Okay, so off to the right, if you look up here, I have verify negative 2 and see how that goes. Right over here. We want to definitely use the original equation, not anything we manipulated, not even this stage there. So first thing I did was plug in the negative 2. And then I put a question mark here to see, is that equal? And then I am going to just calculate that out. So I would get the square root of negative 6 plus 7. Oh, my pen's not working today. So I have negative 6 plus 7 under the square root on the first one, and then square root of 0 that I'm adding on, is that equal to 1? And I do end up with square root of 1, which is 1, plus square root of 0, which is 0, and that does in fact equal 1. So the negative 2 definitely works. Let's now verify the negative 1. See if that works. So just go through the same process. I'm plugging that negative 1 in to each x value and seeing, does it balance? I mean, you can kind of do this in your head once you get the gist, but negative 3 plus 7 under that radical is going to be a positive 4. Then we have a negative 1 plus 2 under there, which would be square root of positive 1. Does that equal 1? Let's see. Square root of 4 is 2. And then we have square root of 1 is 1. Does that equal 1? No, because 3 does not equal 1. So the -1 is extraneous. So we only have one final answer on this one. So that is the whole process. I hope you found that helpful. I can put the actual homework number 11 in a video as well. So look for that one if you still want more assistance. Thanks for watching.